Hello everyone, let's do your exam review together, and you can use this video key as a resource to correct your exam review, or you can check the key, but if you need help on some extra problems, this is it. So number 1 says, given the function, describe the end behavior. Use appropriate notation. All right, so what we're gonna do for that is we're gonna look at the degree, and be careful because it's kind of tricky, it's out of order, but the degree is 4. So the degree is 4, that's even. And the leading coefficient is a positive 6, so that's positive. That means both ends of the function are going up. So with our proper notation, f of x is going to go to positive infinity as x goes to negative infinity. And f of x is also going to go to positive infinity as x goes to positive infinity. And we're doing the same thing for number 2. Let's look for that leading coefficient and that degree. It's the highest exponent on any variable right here. So the degree is 5, and that leading coefficient is negative 5, which is negative. So that means our graph is going to be doing something like this, okay? So as f of x, as x goes to negative infinity, f of x is going to be going to positive, and as x heads to positive infinity, f of x is going to be going to negative. All right, for number 3, it says write a polynomial function in factored form such that the intercepts and end behavior match the following graph. Okay, so we don't necessarily have to worry about what the a value is, but I see right here I have an intercept at x equals -1, so that's a factor of x plus 1. And I see I have a factor here at 2, which is x minus 2, and that has to be at least degree 2, okay? And since as x goes to negative infinity, f of x goes to negative, and f of x goes to positive, I know that the a value is positive because we've got this kind of end behavior. So I don't know, here's an example. F of x equals x plus 1 times x minus 2 squared. Write a polynomial function in factored form such that the intercepts and end behavior match the following. Okay, I can see that I have an intercept right here at 1, so that factor is x minus 1. It's got to be degree 2 since we have a bounce, and x minus 3 since I've got a factor intercept at 3, degree 2 since we have a bounce. And I noticed that both ends are facing down, so I don't really know what a is, but I know a is negative. So here's an example of what you could write right here. F of x equals negative x minus 1 squared times x minus 3 squared. All right, let's move on to number 5. Rewrite the function in standard form. Okay. So let's reorganize this. Okay, so our biggest degree here is going to be 5x cubed minus 6x squared. There's a minus 3x plus 2. All right, the leading coefficient here is just 5. The end behavior, since this graph is an odd degree, the degree is 3. And the leading coefficient is positive. We've got negative to negative, positive to positive. So as f of x goes to negative infinity, x goes to negative infinity. And as f of x goes to positive infinity, so does x. And that y-intercept, I can read it out here on the end. It's going to be 0, 2. All right, rewrite the function in standard form for number 6. Let's do the same thing. The highest degree right here is negative 7x to the 4th. Then we've got plus 8x to the 3rd, minus 3x squared, minus 9x, plus 11. So there, that's the nice standard form right there. Our leading coefficient is that negative 7. So since we have an even degree, the degree is 4, that's even, but the leading coefficient is negative, so that means both ends are facing down. So as f of x goes to negative infinity, x goes to negative, and as f of x goes to negative infinity, x also is going to positive. Okay, and the y-intercept we can get right there from the end of the equation again. It's going to be 0, 11. All right, let's turn the page. It says match the function with the correct transformation of the graph. Explain your reasoning. Okay, so what's happening here is I have minus 2 indicates a shift to the left, to the right. Shift right 2 units. Okay, over here, f of x for number 8, x plus 2, inside the parentheses, plus 2. So this x plus 2 indicates a shift left. Okay. And the plus 2 on the end means down 2. So if you didn't notice, this is your original graph of f, and then a, b, c, and d are the transformations that occur. Okay, for number 9, x minus 2 means shift right 2, and the plus 2 means also up 2, and f of x minus 2 for number 10 means we shift down 2. All right, so let's go ahead and look at the graphs right here. So let's look for the one where we shift right 2 units. So this particular graph, we're just shifting right 2 units. That looks like it would be B. Another option is we keep the graph exactly where it is and we just shift down 2 units. That would be number 10 and C. What about this one? We shift left and down. So we're shifting, oops, I didn't mean to put C. I meant to put A right there. Sorry. Right here, this should be A. I don't know why I put C. Okay, so we're still having C. Okay, so let's look at this. We shift right 2 and up 2. So from this central point, right 2, up 2, we expect that to be somewhere here, like D. And then left 2, up 2, we expect that point to be right here, just like graph C. All right, let's do number 11 where it says to write the graph in standard form. So in order to get this in standard form, we see we've got a binomial to the power of 3. So we're going to write this out, 2x plus 3 times 2x plus 3 times 2x plus 3. Let's FOIL together the first 2 terms. 2x times 2x is 4x squared. 2x times 3 is a positive 6x. 3 times 2x is 6x. And 3 times 3 is 9. We can go ahead and combine like terms to get 4x squared plus 12x plus 9. And now we're going to bring down that last binomial and multiply them together. 4x squared times 2x is 8x cubed. We've got 2x times 12x, which is going to be a positive 24x, and 2x times x squared, 2x times 9, which is going to be 18x. Let's multiply the 3 on the bottom. 3 times 4x squared is going to be 12x squared. 3 times 12x is going to be 36x. And 3 times 9 is going to be 27. I just like to stack them up so that I can combine like terms easily. 8x cubed plus 36x squared plus 54x plus 27 is our final answer for that one. Okay, let's do it again in standard form on this problem number 12. Let's leave the 1/2 x plus 1 for the very end. And let's expand and FOIL out that x minus 4 squared. We'll get x squared times minus 4x plus 16. And when we combine like terms, we'll get x squared minus 8x plus 16. Let's FOIL in this x plus 1 and do the 1/2 last. We will get 1/2's in the front. X cubed minus 8x squared plus 16x. And we'll do minus x squared, plus x squared minus 8x and then plus 16. Let's combine these. We've got the 1/2 in front still. X cubed minus 7x squared plus 8x plus 16. And when we distribute that 1/2 in, we'll get 1/2 x cubed minus 7 over 2x squared plus 4x plus 8. Okay. For number 13, it says factor completely, and you can factor using your method of choice. Regardless of your method of choice, it's probably a good idea to take your GCF out of 5x cubed, and we'll be left behind with x squared minus 2x minus 8. And now we can just use the x method. What multiplies to -8 and adds to -2? We've got 4 and 2, but I need the 2 to be positive and the 4 to be negative. So 5x cubed, x minus 4 times x plus 2 is as far as we can go right there. For number 14, I can see that I'm going to try and factor by grouping since this is degree 3. The GCF here is going to be a squared. I'll be left behind with 2a minus 7. And my GCF between -8 and 28 is going to be -4. And I'll be left behind with 2a minus 7. Now I can group together the front terms, the GCF terms, a squared minus 4, and the repeater term. And a squared minus 4 is the difference of squares, so I've got a plus 2, a minus 2, and 2a minus 7 as our final answer. Okay, let's turn the page. Number 15 says, given that x plus 2 is a factor of f of x, factor f of x completely. Okay, so we're going to use our long division first. X plus 2 dividing x cubed minus x squared minus 24x minus 36. We want those first terms to match, so let's multiply by x squared. We'll get x cubed plus 2x squared, and when we subtract, we'll get -3x squared and drop down the -24x. To make a match, we'll multiply by -3x, -3x squared minus 6x. Be careful of your double negative right there. -24 minus -6 is a -18x. And drop down that -36. We'll be multiplying by -18 and get -18x minus 36, which is what we want, and 0. Remember, if you don't get 0, something is wrong. We should check our answers. Let's factor this further. What multiplies to -18 and adds to -3? We've got 6 and 3, but I need the 6 to be negative. And when it says factor completely, make sure you list all of the factors. So f of x equals x plus 2 times x minus 6 times x plus 3. And we just want to check, since this is a degree 3 polynomial, we should have 3 factors. Let's move on to number 16. It says given 3, 0 is an x-intercept, factor f of x completely. So we're going to divide by x minus 3. 4x to the 4th minus 4x to the 3rd minus 25x squared plus x plus 6. It's a little bit longer, but that's okay. We're going to multiply to make the terms match by 4x cubed. And we'll get 4x to the 4th minus 12x cubed and subtract. -4 minus -12 is a positive 8x cubed. Drop the -25x squared. we're going to multiply by positive 8x squared and get 8x cubed minus 24x squared and subtract. Negative 25 minus negative 24 is negative x squared. Drop the x. We'll multiply by negative x and get negative x squared plus 3x. And when I subtract, I get 1 minus 3 is negative 2x. Drop the plus 6. And we're going to multiply, last but not least, by negative 2 and get negative 2x plus 6. That's perfect. We get it remainder 0. And if we didn't, we made some kind of mistake. Let's factor this top polynomial, 4x cubed plus 8x squared minus x minus 2. We're going to use grouping here since we've got a degree 3. The GCF is 4x squared times x plus 2. And my second GCF is negative 1, giving me x plus 2. I've got 4x squared minus 1 when I group together the GCF terms, then the repeater term. And this is a perfect difference of squares right here, 2x plus 1, 2x minus 1, and x plus 2. But don't forget, when you're writing factored form, you want to write all of the factors. So don't forget that x minus 3 times 2x plus 1, 2x minus 1, and x plus 2. Degree 4 polynomial means we're looking for 4 factors. All right, let's move on to number 17, where it says sketch the graph by hand, x-intercepts with multiplicity. So let's look at our first factor. X minus 6 has an intercept of 6, 0, multiplicity 1. That means we're going to cross the x-axis, 1 because it only appears one time. Our next intercept is going to be negative 1, 0, multiplicity 1, which means it's going to cross that x-axis. I only see it appear one time. And our last intercept is going to be 2, 0, multiplicity 4, which means it's going to bounce. And the y-intercept, I'm going to plug in x equals 0 for that and get negative 2/3 times negative 6 times 1 times negative 2 to the 4th. All right, negative 2 over 3 times negative 6 over 1 is going to give us 4 times 1 times 16, which is going to be 64. So our y-intercept is 0, 64. So let's go ahead and sketch this out over here. We're going to have cross at 1, 2, 3, 4, 5, 6, negative 1, and 2. Our end behavior, this function has degree 6 with leading coefficient negative. So that means both ends are going to be going down. So I'm going to have a bounce. Oops, I put a 0 at negative 6. Sorry about that. Let's move that. Put a 0 at 1, 2, 3, 4, 5, 6, positive 6, negative 1, and 2. Okay, we're good now. So at negative 1, we cross. We go hit our y-intercept of 64. And we come down, and at 2, we bounce. And then at 6, we come back and we cross. Something like that. Okay. Number 18 says analyze the graph and determine the following. So what's the degree of this graph? I can see I have 1, 2, 3, 4, 5 crosses and 5 intercepts. So that means the degree is 5. Number of real zeros is 5. The sign of the leading coefficient, because negative infinity is going to negative infinity and positive is going to positive, the sign of that leading coefficient is positive. The function's odd. And the end behavior is f of x is going to negative infinity as x is, and f of x is going to positive infinity as x is. Number 19, sorry if this got cut off a little bit. It says select the values a, h, and k for the function to model each transformation. All right, so the graph is translated 2 units up and 3 units left. So g of x equals 2 units up, 3 units left. So left is going to be x plus 3, and up is plus 2. The graph is translated 2 units right and 3 units down, okay? G of x is equal to 2 units right, x minus 2, 3 units down, minus 3. The graph is a vertical stretch by a factor of 2, so that's our A. G of x equals 2, followed by a translation of up 2 units, that's just x then, plus 2. The graph is a translation 3 units right, all right? And a vertical shrink by a factor of 1/2. There's our A. 3 units right is x minus 3. And translation of 4 units down, so it's going to be minus 4. All right, and last but not least, it says use the following graphs to answer 20 through 21. So identify all odd degree functions. So if the functions and behavior is going in different directions, they're going to be odd, okay? So odd degree functions would be not A, not B, C is odd. Okay, D, odd. Not E, not F, not G, H is odd, and not I. So this is kind of cut off, so I'm going to write the answers down here. Part B asks for even functions. That's where both endpoints are going the same direction. That would be A, B, E, F, G, and I. Letter C actually asks us, let me just check, to identify all of the odd functions, okay? So odd functions are functions that have symmetry about the origin, and even our functions are symmetry about the y-axis, okay? So right here, for A, we have symmetry about the y-axis, that's even. B, we have neither, so this is neither. C, neither. Actually, no, it's about the origin. So C is neither. Sorry, I don't know why I wrote it in odd. C is neither. D is odd. E is even. F is neither. G is even. H is odd. I is neither. All right, you guys. Hope you enjoyed this review video. I'll see you later. Bye.